Hey everybody, this is Alex Merced from alexmercedcoder.com, and what I want to do today is just kind of go over functional programming within JavaScript. Just kind of go over some of the basic functional programming concepts and just show you examples in JavaScript. So first, let's just explain what functional programming is. It's just a style of programming. There are certain languages that are designed purely for that style of programming. Think languages like Haskell, Lisp. But the idea is that you use functions as your fundamental unit of computation. So everything is done in functions. And when they use functions, they want to only use what's referred to as a pure function. Okay, that means a function with no side effects. Stuff goes in, something else comes out. So let's show you first sort of an impure function. So const. So first we'll say, hey, here's my array, which my array will equal 1, 2, 3, 4, 5. Okay, const my array 1, 2, 3, 4, 5. Impure equals. Let's do it this way. Const equals. We pass in my array, an array. Sorry for all the sirens. I live in Brooklyn. Okay, so the sirens have calmed down, so let's keep going. Okay. Okay, so array. So this is what it's going to do, is just say, hey, let's array dot push 6. Okay, save. Now this is an impure function because I put something in, it doesn't give me something new on the way out. Instead, what it does, it mutates what already exists. It's actually going to change the array. So if I console log the array, console.log my array, we'll see that my array now has 6 inside of it. Node. Let's see here. Let me think about that. Push. Dot push 6. Why did it not? Oh, I never invoked a function. Impure my R. Cool. Save. So I put my R in, and my R comes out different. Okay, this is what's when, and then basically that wasn't even returned. Okay, so when anything changes outside of the, it's basically I change anything outside of the function, that's referred to as a side effect of the function. And generally in functional programming, you don't want side effects in your function. You just want the function to return you a value, and that's really all you want the function to do, to give you back the thing. Okay, that's separate from the things you put inside of it. So a pure version of the same function, okay, would be this. Okay, so R, my function, okay, and then let's say we do this. Return, or what do we do this? Const result equals a new array called my R, which we're a new array that includes all the elements of my R. So it includes all the elements of my R plus 6. And actually we could just return that. We don't even need to do all this. Return. Okay. So it's the same thing. I'm going to end up with a 1, 2, 3, 4, 5, 6, but it's not changing the original array. It's giving me a new one. So now, if I console log the array, but we also console log the result of pure, okay, now watch what happens. Save. See, the result of the function adds the 6. But the original array, my R, console logged here, doesn't change. That's a pure function. I put something out and I got something else back. And that's literally what all the functions should be doing. You're giving it information and then it gives you something new back. You never want to mutate the old stuff. That's this whole idea of immutability. Okay? So in that case, if I want to do several things, I would then just pass in the result of this function to another function, and then to another function, and to another function. And at the end of a chain of functions, I have what I want, but all the stuff I created from step 1 to step 2 hasn't changed. So I can kind of monitor where things kind of fell apart if something goes wrong, because I can see the data in each step. So that's at its core what it is. But the idea is you're just working with functions all around and trying to create solutions by using functions. So a popular solution is what's referred to as a higher order function. It can also be referred to as a functor, I'm pretty sure. But this idea is a function as a wrapper. Okay? You see functors or higher order functions very typically in arrays in JavaScript. Okay, so for example, if I wanted to create a function that adds 1 to every element of an array, I would have to do this. Const add 1 array. Okay, we pass in the array. And then basically what we'd have to do is do a for loop for I equals 0, as long as I is less than the array.length. And then each time we do I++. And then we actually have to create a new array. So const new array equals an empty array. Okay. And then basically each time we loop, we're going to take our whatever, we're going to take the new array and push a value into it. Array.push. New array.push. And we are going to push the result of the array element at that index plus 1. Okay, and then at the end we return new array. Let's see here, where did we go wrong there? Oh, equal sign. Save. There we go. So now, if I were to console log the result of this, array add 1r. We'll just actually put the array in there. 1, 2, 3, 4, 5. 1, 2, 3, 4. That's what we get. Should just add 1 to each and return me an array with each one added with 1 plus. Okay, that's fine. But really, this function is doing two things. Okay, it's running a process on a function repeatedly, or on an array element, and then the individual adding of 1. So instead of making one function that does both things, how about I break this down? Okay, so we'll just change this into fake map, because literally we're just recreating the map function, and instead take out the actual pushing of 1. So control X. So we'll still keep the array, but then we're going to have a function. Actually, let me think about that. Yeah, a callback. Okay, I mean, this is basically how map works. Okay, so we have, and then we're going to run this callback on this array every time. Okay, and this callback will return a value each time. Literally, if you've done map before, you know where this is going. And in this callback, we're going to pass in the array's value, array I, and we'll pass in the index, so that way you have access to that too. Okay, so now basically what this function does is just runs whatever function we pass into it on each element of the array. So now what I can do instead is just add the add1 function here as a separate function. Return value plus 1. Save. So I could separately make a function called add1. I could use it on one value, or I could just stick it in this function and it would do it on every item in the array. So I separate those two concerns. So now I have two functions that I can use in several different situations. Not just, now I don't have to make an add1 function for arrays and then an add1 function for individual things. I just make add1 for an individual item, and when I need to do it on an array, I stick it in map, or in this case fake map. Let's see, it works. Oh, or I broke it. Oh, it's because this still says add1r, so this is a fake map. save. Cool. Okay, so that's the idea of a higher order function or a functor. It iterates over, like I think the functor aspect is more like that it iterates over the array and brings you back a new thing. The higher order function is just more like the function that acts as a wrapper around something else. Kind of like in React, there's higher order components, which are like components you wrap around other components to do things. Okay, so the idea is you can use functions as wrappers and break apart the things that a function does, so that way you have these wrappers that do things you may do in other contexts. Okay, because the idea is, why write the same logic twice when you can break apart the logic into several pieces and wrappers that you can reuse. Okay, so you sit there and you just take a look at the function that you've written and say, hey, can I break this up into several usable pieces? As we did here. Okay, separated the actual what it does to each item of the array versus the act of doing something to every item of the array. Cool. Then there's something called closures. The concept of closures is taking advantage of scoping in functions. So for example, and this React uses this a lot for how it handles hooks. I've been using this a bit more in a lot of different things that I've been doing. But basically the way it works is that we have my function, const my func equals this. Okay, and we have a variable here, my var, which equals 6. Now that variable, typical programming scoping is that it only exists within the function because it's declared in the function, so that's it's scoped to that block. But maybe you want to have access to it outside the block. So what you may do is define return functions from within the function. So the function would return something like this. We'll return an array of functions. The first function basically is what it's going to do is just return my var. So whatever the value of my var is at the moment, it'll just return it. And the second function, as you can tell, it's a very busy part of Brooklyn. Pause it for a moment. Okay, here we go. So the second function, which we do pass in a new number, what it's going to do is just say my var equals num. Okay. And this is technically an impure function, so this is not strictly functional programming. To keep it strictly functional programming, you'd only get back that information. Okay. Or create a new function with a new variable and then return you could play around with it. But this illustrates the idea that basically, since these functions are created within this function, okay, they still technically have access to my var because they were created here where my var is still in scope. So now I can do this. Const, since the first function gets the variable, we'll call it getter. And since the second variable changes the variable, we'll call it setter. Okay, so getter and setter equals my func. Okay, so first we'll try out the getter. So console.log getter. That should console log 6. Now what we're going to do is we're going to use the setter to change the variable to 7. And then we're going to once again console.log getter. And again, there's no other way for me to console log the number because I can't console log my var because my var doesn't exist outside of the function definition. But because of this getter function that was returned to me, this getter function still has access to inside the function, so I can use it to grab it from the outside. This is so the idea was called a closure. So that variable is enclosed in the function, but these functions allow me to break through that enclosure and pull out and manipulate data. So save. Okay, and then what did I do here? Oh, it's because I declared it a const. So this needs to be a let. Oh, function variable declarations. There we go. Okay, so see, originally was 6, then I changed it to 7, then it came back as 7. Okay, cool. And again, I'm accessing and manipulating data within a section of the code that I normally should not have access to. That's the beauty of closures. And then this allows you to kind of create all sorts of weird data structures within a function that can be very class-like. Okay, so where you can kind of practice pseudo object-oriented programming from a functional language, even though they won't have things like classes and inheritance and whatnot. By taking advantage of scoping, you can play some fun games. So that's closures. There's another thing called a monad. Basically, that would, if I were to go back to the map function. Okay, essentially, flat map is a monad, what's called a monad. Basically, what a monad is that it's going to be a functor, so it's going to basically iterate over it's a wrapper that iterates over an array, but at the end it'll flatten it. Okay, and this is essentially technically what you're doing when you're working with promises in JavaScript. So it's kind of hard to illustrate. So basically, what happens is that in JavaScript, you have this thing called a promise. Now, initially, when you first return the promise is really a object with 3 properties. It's I think it's like error, pending, and response. Okay, and then basically, this will be null at first while it's waiting for the promise to resolve. This will be true because it's currently waiting for the promise to resolve, and this will be null because it's waiting for the promise to resolve. Okay, so you have this sort of data object, and then when it's done, let's say it goes back and it fetches your result, and it's done. This becomes false because it's no longer pending. That error stays null, but response then becomes has data in it. But the thing is that you don't want to have to sit there and be like response. You go access this response property by itself. So what happens when the promise resolves? It kind of removes all of this. It flattens it, so that way all that's really left is the actual response from the promise, the actual data so it flattens it to what you need. So that pattern where basically something does something, and then when it's done, it just smushes itself. That's a monad as far as I understand it. Okay, so in that case, I don't have to sit there and go fish out that data. It's brought up to the top once the promise is completed. Okay, so essentially, yeah, something to that extent. I won't say that I'm completely super knowledgeable about monads, but that is sort of kind of what I appreciate them as at the moment. Okay, so essentially it's a functor with flat map. It flattens. Cool. And aside from that, I think that kind of covers most of the basic ideas. Again, the basic concepts are things like immutability, pure functions, higher order functions, so the wrapper functions. Again, so the idea is just how can you use functions to solve problems in different ways and avoid mutation of data, avoid function side effects. Basically, all functions should really be something comes in, something else comes out. You guys have a great day. I'll talk to you guys later. Have a good one. This is Alex Merced from alexmercedcoder.com.